In 1803, John Dalton proposed the modern atomic theory of matter. Although some of his basic assumptions were correct, he had no means of proving his theory. More than 20 years later, in 1827, Scottish botanist Robert Brown made a discovery that provided the first vivid evidence of invisible moving atoms. Brown was studying pollen grains suspended in a drop of water. As he observed the pollen grains under a microscope, he noticed that the grains moved in a random, zigzag motion. At first, Brown thought that the particles were alive and moving under their own power. To test his hypothesis, he repeated the experiment, this time with smoke particles. He observed the same random motion in the smoke particles, which he knew were not alive. He had to conclude that some force caused the particles to move, although he had no idea what the force could have been. He carefully reported his observation of this phenomenon, which was dubbed Brownian motion by later researchers. It was not until the 1860s, after James Clerk Maxwell proposed the kinetic theory of matter, that Brownian motion was explained. Pollen grains in water move because water molecules, which are constantly moving, bump into the grain. Water molecules move quickly, and a particle suspended in water is usually bombarded equally on all sides. When the number of collisions is about the same on each side, the particle does not move. Occasionally, however, the number of collisions is greater on one side of the particle. When this occurs, the particle moves away from the collision. Because of Robert Brown's discovery of Brownian motion, scientists developed the kinetic theory of matter, which is stated in the kinetic theory of matter deals primarily with the motion of particles within matter. The rate of motion and the distance between particles is different for each phase, solid, liquid, gas, because particles within a solid are closely packed. Their motions are restricted to rapid vibrations within a narrow space, and each particle exerts a strong force of attraction for the particles near it. The strong attraction confines a solid to definite volume and shape. The particles in a liquid are not so closely packed as in a solid. Since the particles are farther apart, the attraction between them is not as great, and the particles have more freedom to move, because the particles still attract one another. A liquid maintains a definite volume but does not maintain a definite shape, because the particles of a gas exhibit very little attraction for each other and may be very widely scattered, as a gas has neither definite volume nor shape. The kinetic theory of matter also explains how much matter in one phase can change to another phase. The particles in a solid possesses a relatively low energy level and a low activity level. At this low level of activity, the force with which they collide with other particles is slight. If heat is applied, the particles within the solid absorb heat energy. As each particle's energy level increases, its activity increases. The number of collisions between particles increases, and the force of each collision increases. Because of the additional force, the particles begin to overcome the strong attractive force between particles, and the substance becomes a liquid. If heat continues to be applied, the energy of each particle increases the force of collision increases. The distance between particles increases. The attractive force between particles is completely broken and the substance becomes a gas. That's it for today, this video. Thank you for watching. Bye.